Ave Coders. In this video, we'll talk about the unit tests. So the very basic mechanism of testing your code, well, after the print statements, of course. In general, unit tests make evident that even the smallest parts of your code work as they should. And this is why they're called unit tests. So why do we need them in the first place? Well, the fact that program currently works as it should is not really a good indicator that it will always work as it should, because at some point we'll want to add new features, new users, new edge cases, and so on. So when our program will start to become more complex, a little edge case that went unchecked can potentially collapse the whole thing. Therefore, we need a statistical confirmation that all parts of our code deliver the expected result. There is even a whole concept or software development process called TDD, for test-driven development. In short, it implies that you don't write a piece of production code unless you wrote a test for the case that this code would satisfy. So first you write the test, and then you write the code that will pass this test. I know it sounds a bit backwards, but once you'll get used to this philosophy, it will be hard to imagine how you would do things differently. I think I'll do a separate video on TDD, but in this tutorial, I'll introduce you to a unit test module that was created specifically for writing unit tests in Python. And I'll introduce you to the fact that you shouldn't be really afraid to write tests, and that it should be your pretty much basic habit. All right, so let's jump straight into code. And for this tutorial, I'm going to be using a very famous example, which is a basic calculator. So inside of our file, basiccalculator.py, I will import math that we'll need to use later, and I will implement a few basic functions that will be addition, subtraction, then multiplication, division, and also raising to power, and the square root. So the addition, subtraction, and multiplication are pretty straightforward functions, but division will raise a value error when we'll try to divide by 0. Same goes with the power function. We are artificially limiting our calculator so it wouldn't be able to deal with the negative powers, and same goes with the square root, where we say that the argument of that function must not be a negative number. So for these three functions, not only we need to make sure that we are getting the correct result, we also would need to make sure they raise a value error in cases when they're supposed to do so. We'll put our tests in a separate file, which we'll call testcalculator.py, where we'll import the unit test module, and also we need to import our basic calculator so we can assess its functions. Once we've done that, we will define a class. We'll call it test calculator, and it needs to be inheriting from the unit test.test case. That way, Python will actually know that the methods we'll define inside of this class are actually test cases, not some regular methods. So this is what it basically looks like. This is the documentation, and as you can see, we have a bunch of methods, and then we use the assertion methods provided by the unit test module to make sure that whatever function returns is actually what is expected. So there are methods such as, for example, assert equal, that compares what function returns with what is expected, and assert true, for example, whether a function is returning a true value, or assert false, and a bunch of others. I highly recommend to browse through the official docs to see what tools are available to us. But let's start with testing the addition function. So it is really important to write test at the beginning in the name, and inside of this method we can use the assert equal method to check whether say, for example, we add two numbers, 2 and 2, and the expected result is, of course, 4. So if everything is correct and the function works as it should, we will get a pass. So we'll get a successful test. Now, if we'll launch this code from our IDE, nothing will happen. So how do you execute a test? Well, there are a couple of ways around that. For example, first is via the console. So we write Python or Python 3, whatever your case is, then -m for module, then the module name unit test, and the name of the file, testcalculator.py. Once we'll run this script, we'll see the output in the console. So we run one test in 0 seconds and the result is okay. And you can also see a dot above that dashed line. So the function ran as it should and returned the expected result. But if we don't feel like running the test from the console every time, we can write the following: if name equals main, and then we run main. For those of you who are puzzled what this is, I would highly recommend to check my video solely on the topic of if name equals main. So just follow the link. But now this if name equals main and then unittests.main will allow us to launch our test straight from our IDEs, like so. We didn't change anything else, so as expected, the result will be okay. And I'm literally going to show you what happens when you don't follow the convention of naming tests with this test prefix, so test underscore and then whatever your method name is or test name is. I'll remove them and we'll launch the code. Rather, I'll swap them around, so now it's addition underscore test, and when we'll launch it, we'll see that it is okay, but we run 0 tests. So Python couldn't recognize which actually method is the test. So this proves that following the naming convention is really important in this case. So let me change these back to where it was. So test underscore addition. And now let's check out how the test fail looks like. I'm going to change 4 to, let's say, 5. Therefore, function returns 4 and we have 5. They're not equal. So we are getting the assertion error which says 4 is not equal to 5. Also, we have F above the dashed line, and the general verdict is that our test failed. And we have a number of failures, which is currently equal to 1. So really, you shouldn't be afraid to see your test failing. Let me reverse it back to what it was, and let's write a few more assertion statements. Theoretically, we can write thousands of assertion statements covering every possible case, but first of all, there is no point in doing so. And second of all, in this tutorial, I'm showing you the basic mechanics of unit tests. So second case is adding a negative and positive numbers. So -2 and 2 will give us 0. And the third one is summing up two negative numbers. So -2 plus -2 will give us -4. And now we see that we have succeeded, but we only see that we run one test. This is because it doesn't matter how many assert, equal, or assertion statements we have within a test, it still counts as one. So let's say we'll have 3 assertion statements per method, and let's move on and implement the next one, which is the subtraction. So once again, I think 3 assertions will be enough. The first one is 2 positive numbers, so 2 minus 2 will give us 0. Next one is -2 and 2 will give us -4 because we have -2 and minus and then a positive number 2. And the last one is subtracting one negative number from the other, so -2, and -2 will give us 0. It doesn't work straight like in, say, math that you can perform on paper, because you have -2, then minus, and -2 again. And then you have multiplication,
which is going to be again multiplying first two positive numbers. So 2 and 2 will give us 4. Then we'll have one negative number and one positive number. Minus 2 and 2 will give us minus 4. And then two negative numbers. So minus 2 and 2 will give us a positive 4. The next function to test is responsible for the division. First case is dividing two positive numbers, so 2 and 2 will give us, of course, 1. Then another edge case is minus 2 and 2 will give us minus 1. And the last case is to make sure our basic calculator can also output a fractional value. So 0.5 is a result of dividing 1 by 2. The function also raises an error when we try to divide by 0, but we'll skip it for now. We'll implement two other functions and then we'll come back and implement this exception thing. So the next one is the power. The first case will be raising 2 to the power of 2, which gives us 4. The next edge case is when you have a 0th power, so you're raising 2 to the power of 0, that will give you 1. And the last one is raising 0 to the power of 2, which will of course give us 0. Once again, we'll implement the exception later after we'll finish with the last function, which is the square root. So the square root of 4 is of course 2. The square root of 0 is 0. So I'll leave just two assertions here. You can write in the comments what other edge cases we could have implemented in this code. But first, let's run it and see if it works. Spoiler alert, it will work as it should. We'll see OK for all tests. We see 6 dots, which are representing roughly the number of tests. And we can see run 6 tests and then how much time did it take us. Let's also check how it will look like when we have multiple tests and one of them fails. So let's say I'll change the first assertion in the subtraction test from 0 to 4. And when I will run the code, I'll see the failure, of course. We have 5 dots and then F. Also, we see the failures equals to 1. And then why it actually failed. So assertion error 0 is not equal to 4. So this is how it looks like. Let me reverse it back and we will get on with dealing with the exceptions. So just to remind you, back in the basic calculator.py, we have 3 functions, which is the division, power, and square root that raise value error. The division function does it in case of the division by 0. The power function is artificially limited to not have the negative powers, and square root function doesn't accept negative numbers. Therefore, we'll need to make sure that these 3 functions raise value error when they're supposed to raise it. And to accommodate this behavior, we will be using a different assertion method that is specifically designed for the exceptions to make sure the value error was raised, and this method is called assert raises. And as you can see, we apply it in the most Pythonic way, with the context manager. So if we'll try to perform the division by 0 and the exception is not thrown, then the test will be counted as failed. And if we'll run the code now, we still have 6 tests and the response is OK. Now let's implement similar assertion statements for our test power method, and is going to throw another exception there. And also for the square root, just checking that it runs and returns OK. And now we're implementing the last assert raises for the test square root with the value -2. And this concludes our introduction to the basic unit tests, the assertion statements, and how to write them. We run the code once again, we see OK, and we're happy.
In the upcoming videos, we'll continue to dive into the testing with Python, so make sure you're subscribed to this channel. And please give this video Emperor's thumbs up, toll the bell. That was V, and I'll see you in a bite.